Theory is a study of mathematical models of strategic interaction among rational agents. It has applications in all fields of social science as well as in logic, system science, and computer science. Any problems with interacted participants and actions can be treated as a game. When car drivers puts a plan to driver in a heavy traffic, they are actually playing a driving game. Similarly, there are many real life situations which can be treated as a game. Game theory is a mathematical tool that can analyze the interactions between the individual strategically. The interactions between agents who may be individuals, groups, and firms are interdependent. These interdependent interactions are controlled by the available strategies and their corresponding payoffs to the participants. Therefore, the game theory will only work when people play games rationally and it will not work on the games with cooperational behavior. Generally, the game consists of the following entities. Player, the one side of the game tries to maximize the gain, while the other side tries to minimize the opponent's score. However, these players can be humans, computer, application, and other entities. The environment. This includes the board position and the possible moves of the players. Successor function. The successor function includes action and the return of list of pairs, where each pair indicates a legal move and the resulting state. Terminal test. The terminal test specifies when the game is over and the terminal state is reached. Utility function. The utility function is the numeric value for the terminal state. The scientists of interdisciplinary community believe that the time has come to extend the game theory beyond the boundaries of full rationality, common knowledge rationality, consistently aligned beliefs, static equilibrium, and a long-term convergence, as it did in the year 2007. These concerns have led various researchers to develop the formal models of social interaction within the framework of a game theory. The first formal study of game was done by Antonio Carnot in year 1838. The mathematician Emil Borel suggested a formal theory of games in year 1921, which was extended by another mathematician John V. Neumann in the year 1928. Game theory was established as a field of its own right after the 1944 publication of the monumental volume Theory of Games and Economic Beer by von Neumann. In 1950, John Nash proved that the finite games have always the equilibrium point at which all players choose actions which are best for them given their opponent's choices. In the 1950s and 1960s, the game theory was extended and developed theoretically and applied to the problems of war and politics. Since the year 1970s, it has created a revolution in the economic theory. Moreover, it has found applications in sociology, psychology, and found links with evolution of biology. Game theory received special attention in year 1994 with the awarding of the Nobel Prize in the economics to Nash Al-Nasra in year 2007. The attractive point in studying game is that models used in the games are applicable to be used in real life situations. Because of this, game theory has been broadly used in economics, biology, politics, law, and also in computer science. Examples on the use of game theory in the computer science include interface design, network routing, load sharing, and the allocated resource in distribution systems and the information services transaction on the internet. Now we'll discuss about the automata types. An automaton, plural automata or automaton, is a self-operating machine. The output to one automaton is the combination between the consequence of the current input and the history of the machine's previous input. An automaton is designed to automatically follow a predetermined sequence of operation or respond to the encoded instruction. There are many types of well-known automata, such as finite automata, Turing machines, push-down automata, adaptive automata, as well as other variations such as random access machines, parallel random access machines, and array automata. Now we'll learn about the learning automata theory. Theory of automata is a theoretical branch of computer science and mathematical. It is the study of abstract machines and the computation problems that can be solved using these machines. The abstract machine is called the automata. The main motivation behind developing the automata theory was to develop methods to describe and analyze the dynamic behavior of discrete systems. Therefore, this automata consists of states and transitions. The state is represented by the circles. The transition is represented by the arrows. The automata is a kind of machine which takes some strings as input, and these inputs goes through a finite number of states and may enter in the final state. Now we'll see about the applications of automata in game theory. Automata theory has presented various types of automata with different characteristics. It has many categories as following. Back in 1985, Neyman tries to model the fact that players can do only bounded computation by modeling interstate prisoner's dilemma player as a finite order. 1 year later, Rubinstein tries to show that costly computation may affect the agent's utility. In Rubinstein's assumption, the player chooses a finite automata to play the game instead of choosing a strategy directly. In 2000, Doddy's were the first who formalized the idea of finite automata in Prisoner's Dilemma instead of modeling players as polynomial bounding Turing machine. Now we'll see about the applications of adaptive automata. Adaptive automata based devices have been presented as a powerful tool for defining complex languages. Adaptive automata have the following important features. The accepting procedure formed by an adaptive automaton is done efficiently due to the structure which is based on finite state or structured pushdown automaton. The adaptive automata can handle context dependency in a strict syntactically way without the aid of auxiliary semantic procedures. The structure of adaptive automata can extend to implement transducers, allowing the generation of a parse tree as a side effect of parsing sentence. Applications of cellular automata. Cellular automata can be a complex system by themselves, or they can offer good ways of studying behavior of complex systems. The presented work in Sicily in year 2008 has modeled the participant agents in a given game as a stochastic learning cellular automata. Stochastic learning means that the behavior is not determined by its shape, but by its consequence. In the same context, other work have modeled the agents differently, such as the modeling agent as a combination of cellular automata and stochastic learning automata. Back in year 1975, Albin was the first person who modeled the checkboards models as the cellular automata. The authors in Zhang, Li Gao, and Li in year 2009 and Cecil Gai in year 2003 have investigated how the evolution of cooperation is influencing the prisoner's dilemma model using cellular automata. We can conclude that present in Su Hui, Zhang, and Li in year 2009, the researchers examined how the spatial structure of environment loss affects the epidemic. They simulated the heterogeneous lattice landscape by defining two environment states, that is suitable and unsuitable. We conclude that the representing the behaviors of n-players prisoners dilemma models using cellular automata has great benefits, since most of the researchers can utilize it to distinguish effects of neighborhood structure and the evolution of cooperative behavior. Conclusion. We can conclude by this point that the more states we have, the higher is the capability for those automata to handle the complex strategies. Thank you.